On this video, we'll take a look at the first two questions on the practice sheet that I've given you for this first week of revision. Question 1 is about a 650 volt supply connected to an induction motor. The line current is measured to be 16.6 amps and lags the voltage by 47 degrees. Going to calculate the apparent power supplied by the source, the active power P from the source, the reactive power Q, and the new apparent power and phase angle if a capacitor is fitted to change the reactive or reduce the reactive power overall to 1500 var. Okay, so starting off with part A. How do we do that?
Supply voltage times the line current.
Yep, so the formula, Danny, is
EX times I.
what is equal to that? S is equal to E times I, and we put the numbers in. 650 times 16.6 equals, what'd you get?
10,798.
V8, units correct, 10.8 kVA. Yep. So typically 2 marks for all that. Yeah. One thing I might take a mark off for is not having the units. Obviously, if you don't get the right answer, I'm going to take a mark off. Okay. One note about the accuracy of values. I'd suggest that you work to 3 significant figures in general. Yeah. Be aware that if an answer comes out at, if you're rounding this 23.123 to 3, sorry, I'll just alter that in a minute. 23.9 87, right? That rounds to 24 exactly, doesn't it? Write it as 24.0. You're showing that it's 24 exactly to 3 significant figures, to the same 3 significant figures as all your other answers. Yep, that's good practice. Probably won't mark you down if you don't do that, but that is good practice. Alright? Because it's showing that you're using the same level of value throughout all your calculations. Okay? So, I think you'll all agree that's a fairly easy 2 marks. You just need to remember that the apparent power is S, and you get it from multiplying the line voltage with the line current, or the appropriate voltage with the current. Yep. Part B. Luke, active power.
I worked out using the trigonometry function cosine 47 degrees equals b divided by x.
Cosine
47
degrees is equal to
b divided by s.
P over S, yep.
And then I'll rearrange that to cos 47 degrees times 10,700.
Yeah, so you rearrange that to S,
E equals
yeah, sorry, P equals S cos 47 degrees. Yeah. Which is,
yeah, so it's three significant figures equals 7360.
10.8 times 10 to the 3. You can use that notation, or you can write 10,800, I don't care, cos 47 degrees, and the final answer is
7360.
you lost a mark at the moment.
What's that? Oh, okay, yeah. The fast
Watts, yep. Okay, so again, 2 marks. Alright, part C. Tom, any ideas? I know you haven't tackled this question yet, but
yeah,
you could do that. Yeah. So what if we look at what we've got here? We now know P is equal to 7360. That's the horizontal part. We know the angle, or we know that cos of that is equal to we know that angle is 47. Yeah.
so we can work that out.
And we know S. Yeah, and part C says find the reactive power, which is that side. So you could take the inverse of 47 degrees, go through the option of doing either tangent or sine. Do you know an easier way than that?
You can use S equals square root B squared plus B squared to rearrange that.
Yeah. So in this instance, rather than do load more calculations with sines, cosines and tangents, you know 2 sides of a right angle triangle, use Pythagoras theorem. Yeah? Alright? So it's about, and this type of thing really helps doing a triangle and getting that relationship down and writing all that what you've found out somewhere on the page. Over to the right hand side, perhaps there's a margin, you can put it in, will help with solving these problems. Okay, so that's a triangle, a phasor diagram, whatever you want to call it, but that's what it is. P is the horizontal, Q is the vertical, and S is the hypotenuse. Alright, so the solution there, the quickest way to the solution is that we know that S is equal to root P squared plus Q squared. Okay, you should know by now that if you take Q out of there, the rearrangement of that is that Q is equal to S squared minus P squared, all square rooted. Yep. And we stick the figures in. 10,800 squared minus 7360 squared equals. And the answer? How did you do it, Luke?
I used sine for the same equals q over s.
Okay, we'll see if we get the same answer.
7891.3 bar 789.
7891 bar 7890 to three significant figures. Yep.
Yeah. 7887.
4 bars out in 7, nearly 8,000.
Haven't rounded very well. Rounded three significant figures would be 789. Well,
Yeah. So you're not significantly out, and you'd be right whichever way you did it. I'm not saying you're wrong to go down the sine route. Just saying once you've got two values in a right angle triangle, Pythagoras theorem is probably the quickest. Okay, but you'd have got full marks, and again there are 2 marks for that. Part D. Okay, the new apparent power and phase angle if a capacitor is fitted that provides reactive power to reduce the overall Q to 1500 volts. So it's currently 7891. How are you going to tackle this problem?
I use the Pythagoras theorem again.
Yeah.
Instead of it's x equals square root of b squared plus b squared.
So you're doing S is the square root of p squared plus q nu squared, we'll call it. Yeah. Try and be specific about what values you're talking about so you can see where they come from. And then we simply put those numbers in. P would stay the same. Hang on, was it 7360? Yeah, 7360. Q nu is the 1500 you've been given in the question. And the answer to that is
7510
volt amperes. Yep. So there's 2 for that bit. And then finally the new phase angle.
I used sine df equals
Yep.
sine minus 1, that's the minus 1, multiplied by q over s.
And that's Q nu, yeah? Because we're looking at the triangle. Again, draw one. You're trying to find theta. This is 1500. This is 7510.
Yeah.
Yep. So that's sine to the minus 1 of 1500 over 7510 equals.
It's 0.2. It's the fraction,
Yep.
which equals 11.5 degrees.
I agree with that. And that's another 2 marks. In my work solution, I have to say, doesn't make any difference, but I use cos to the minus 1 and I've done P over S nu. Yeah, but that don't make any difference which ratio you use. You could even use the tangent ratio if you wanted. Alright. Yeah. So that is question 1, gentlemen. Question 2? So we have an inductor of inductance 35 millihenries, and a resistance of 16 ohms, connected in parallel with a further resistive load of 34 ohms to a 110 volt 50 hertz source. Probably a good idea here to draw a diagram, so I'm going to just quickly do that. So don't take very long, just clarify from a worded question like that, what does a circuit look like that you've got. Really useful. So reactance of the inductor, Dan.
2 pi F.
2 pi FL. So that's 2 pi times 50 times, how have you written that? 35 times 10 to the minus 3, and the answer is
0.228.
0.22 ohms. Everyone agree with that? And what I got either. I got 11 ohms too. Yep. So I'm just going to add that on my diagram. XL 11 ohms. Always useful to do that. Again, 2 marks. Right? Looking puzzled, Luke.
No, that's fine. I got that.
No, good. Good. Total impedance. It's in parallel.
I've done the product over sum to get turn them two resistors into one.
Yeah. You get 10.88.
You've done product over sum just on the 2 resistors.
Yeah.
You can't do that because those 2 values are in series, and that series combination is in parallel with that.
So just that.
So you've
27 resistor rather than.
no. What you've got to do is add those 2 together because they're in series,
Yeah.
and then you've got to parallel them up with the 34.
Yeah, that's what I mean. So the 11 resistor will become effectively a single 27 ohm resistor.
But as complex, remember. So the total impedance of that bit is a complex value because it's got an inductor and a resistor in it. So you can't just say us 16 ohms plus 11 ohms because remember you've got an angle associated with that XL. So you've got to use the complex values. So we can write an expression for remember this bit of the circuit is one inductor represented by its inductance in henries in series with its winding resistance. So we could say that that is ZL, and this is ZR. So if we combine those two together and call it ZL, and we call the resistor here, because we're AC, call it ZR. Now can you write an expression for the total impedance of that circuit in terms of ZL and ZR? Pause the video and see if you can do that. Right, who's brave enough to have a go at what the expression is for ZT?
ZR plus ZL.
That would be the impedance of the inductor. That would be what ZL is. So ZL equals the trouble is we call that ZR. ZL is RL plus XLJ. Yep. So that's the first step. That's those two bits added together. I think I need to go through this bit of this question, so I'm going to do it. Alright. So that's those two bits added together. And in terms of, so we're calling this bit here now RL, okay, and we know that's called XL. Yep, we added those two together. But an expression for the total impedance is, remember someone mentioned product over sum. ZL ZR over ZL plus ZR. Yep. All got it now? Now we need to substitute the values into that expression. So we've got equals ZL is RL plus XLJ, and we've got to multiply that by ZR. Yeah? And then we're going to divide that by ZL, which is RL, plus XLJ, plus ZR. And now we can put our numbers in. RL was 16 plus 11J. We're going to multiply that by the 34 ohm resistor and divide that by, we've got 16 plus 11J plus 34. How do we do this multiplication, Tom? Top line.
34 plus 16. Sorry, 34 times.
34 times 16,
Yeah.
which comes out at 544. And, Tom?
At the one below.
No, we haven't finished this yet.
Sorry, oh, plus 11J.
Remember,
34 times that.
34 times 11.
34 times 11.
Yeah, but J. So it's going to be plus whatever 34 times 11 is. You've got to multiply everything in the brackets by everything that's outside it, remember. Yeah? 300 that's the top line. Yeah. And down the bottom here, we just bring together like terms. So we can add together the 16 and the 34. 50. And then plus 11j. Now what do we do? What are you confused with, Luke?
Why is it if you're only if you can only add like terms, why are you able to multiply terms so much?
Because top is multiplication, the top line is product,
Yeah.
the bottom line is addition.
Yeah. But why is it that you can multiply j number by a simple number and you can't add?
You can multiply two complex numbers together using rectangular form if you want to. We've done that. But this effectively it is you could say that this is a complex number but it's got no j term. If it did, you could still multiply it together, but what do we generally do when we want to multiply or divide complex numbers? Put them in polar form because it's easier. Yep.
Is that what you go with plus 3?
You can add these together. We've got 1, 2 real parts. Just add them together. And add all the imaginary parts together as well. And write them down like that. So we got a 34 and a 16, the real parts. If we think of it in terms of, if we drew that on a diagram, we're saying we're going to add a vector that is 34 long to one and none up to one that is 16 along, about halfway, and 11 up. We're going to add those two vectors together. That's what we're saying we're doing there. So the resultant is in there somewhere.
So it's in polar form.
So that's that bottom line. That would be 50 long, 50 this way, and 11 up. That's what that would be. Yeah? We added the two together. But that's what that maths is doing. But just as an aside, it is allowable to do 6 plus 2j times 3 plus 2j. You can do that. We cross multiply everything. So we do 6 times 3 is 18 plus 6 times 2j is 12j. 3 times 2j is 6j. 2j times 2j is 4j squared. Yep. What's j equal to? Square root of minus 1. So j squared, if we square that, we have to end up with what's inside it. J squared equals minus 1. So we can say we've got 12 plus 6j, altogether we've got 18j. Yeah, and here, this is minus 1 times 4. Yeah, because that's minus 1. So it's 18 minus 4 is 16 plus 18j is the result of that multiplication. But most of the time, we haven't been doing that. We've been converting to polar and then multiplying in polar form. So we've been writing down in the 12 angle 6 degrees times 5 angle 20 degrees type form, where you do 5 times 12 is 60. Tom, go on.
Yeah, no, that's it. Then
And 6 plus 20 is angle 26 degrees.
Yeah.
Yeah?
Because if you just have 12 angle 6 times 5, you just times 12 times 5 and then you're done.
Yeah, because the angle is if an angle's not mentioned, you assume no angle. Yeah. So the angle, if you've got a all real thing like a resistance or a power where there is no angle, and you just multiply that by the magnitude, and the angle stays the same. All right. But multiplication, we multiply the magnitudes, add the angles. Division, we divide the bottom magnitude into the top and subtract the angle. Okay, so that's a bit of an aside, but we got to get that complex arithmetic off by packing away. So, having done that, what we need to do is convert those. What you need to do is convert those to polar form. Make it easier. Right, what we got for the numerator in polar form? Top line. 660. Looks good to me. Angle 34.5 degrees. Luke, what you got for denominator? Angle. Yep. Exactly what I've got. Yeah. So that division, the result of that division. So 12.9. .1. Yep. The question's worth 4 marks. You're currently on a loss of 1 mark. Yep. Goes in there. Alright, so 4 marks for that bit. There's more work in it. That's worth more marks. Have a go. See if you can finish off parts C, D and E now.
Sorry,
So, what's the next part? The next part is to find total current flow. So I is
equals dt.
yeah, 110. We could add the angle for completeness if we want to show that. And the total impedance is 12.9, angle 22.1 degrees. The result of that division is angle 22.1 degrees. And like I said, we check that word civil. We're looking at that half of the word because we know we've got an inductive load, and voltage is before current, current after voltage, current is lagging the voltage, negative angle. Yeah, we got it right. Okay, so for that part of the question, hang on, the one before here, this one was 4 marks. That's 2 marks. Again, drop units and things, I tend to take mark off. If you got the angle wrong, didn't put the minus sign or something, take the mark off. Alright? And then lastly, power factor. Is equal to how we done it? Yeah, cos of the angle. So that's cos of minus 22.1 degrees. Yeah. Yeah. The idea is the section, the short answer section, as some banker questions to get some marks on the board, some easier, more lead questions before you go into more depth in section 2. Yeah, you need to get 40 to pass. It's unlikely that you're going to get all 40 unless you're really good anyway. You're then going to be getting a load more marks in the other section to get a good grade. Yeah, but if we've already seen a little bit of a stumbling block in there around the calculation of the overall impedance. What you need to be careful of there is wasting a lot of time, and very much make sure you look at the whole paper before you start anything. You don't have to do them in any particular order. You don't have to do the section 1 questions first. You can start with question 5. I would do the 4 smaller questions first, but you don't have to do them in the order they're presented. Okay? So get the questions you know how to do out of the way. But to do that, you need to read the whole question, because it's very easy to wade in with one that looks easy to start with, and then come up against a big stumbling block and waste a load of time trying to get over it. So read the whole paper, just briefly, to make sure which question is your bank, or which one can you get the most out of. What's the next one I can get the most out of? So that way you use your time wisely and only do the ones that you're going to struggle a little bit with towards the end. Okay? Please don't get the impression that you're going to get extra marks by attempting some of a third question in section 2. Okay? What will happen if you answer more questions than you've been asked to is that the ones you do first will be marked, not the one you got the best result out of. So if you want a part of your work ignored, strike it through. Please ignore and do the other question. If you get completely stuck and you want to try the third question, make sure you let me know. I've struggled with that one. I don't want that one marked. I want the other one marked.
Make sure you write black pencil up. Whenever it happens, exam like pencil before. I get told by the people who've got to go over that all. Really?
Yeah, someone could change it if it's pencil.
Okay.
So you do it in, yeah, pen, yeah. Alright?
Okay. How was the last actually?